Okay, so you just watched a video where the cook made a reduction. So why does that work? So what is the science that we can apply that we learned on Tuesday to understand why a reduction thickens a sauce? Well, if we think about our reduction, it's basically water filled with particles. So that's the starting point. That's what the chef puts in the pan. In addition, he also had some butter to thicken it up, which adds basically oil drops. So that's more particles. Um, but while he's reducing it, what is he doing? He's just boiling away the water. Why would boiling away the water lead to the sauce getting thicker? Well, if we have all these particles in the water and we remove the water by boiling it away, what we're left with is a higher volume fraction of particles in our water. Remember, we talked about volume fraction last lecture. So as we remove the water, we increase the volume fraction of the particles. And by increasing the volume fraction of the particles, we increase the viscosity and thus thicken the sauce. So this is the way that a reduction works. You remove the background fluid, which thickens the sauce because the particles that remain are at a higher volume fraction. Okay, next up, let's talk about starch-based thickeners. How do we thicken a sauce using starch-based thickeners, right? And that's, an excellent example of that is bechamel sauce. So there, we start with our sauce and we add starch to it. Right, so we have these little starch granules that are floating around now in the sauce. As we heat the sauce, the starch granules undergo what's called a gelation, which means they suck in the water around them and they grow. Okay, you can imagine this is like taking a really perhaps dried up sponge and putting it in water, and as it sucks in the water, it gets larger and larger. So water gets sucked into the starch granules, and they begin to swell with water. So these small starch granules, after being swollen with water, becomes quite large. In addition, some of the individual starch molecules, in particular amylose and amylose pectin, begin to leak out. So that's what these little tails and arms are here. It's just the molecules of starch leaking out of the starch granule. Well, these large swollen granules now are taking up a larger fraction of the volume. So the volume fraction of our starch granules has increased. And as we know, if you increase the volume fraction, you also increase the viscosity, which means you've now thickened the sauce. To repeat, you add starch granules. When you heat them, they undergo gelation and swell. In addition, they begin leaking out some of these molecules. The large starch granules plus the molecules restrict the flow of the fluid around it, which then thickens the sauce. Here is a diagram kind of showing this effect. So we start with our starch granules, which then swollen and then leak out starch molecules, which form a network, which ends up thickening the sauce. And here's a scanning electron microscope, which is a high resolution microscope image of a starch granule with this starch molecule network all around it. And you can see why something like this in a fluid would help thicken the fluid. All right, now what are some of the detriments of starch-based thickeners? Well, they need a lot of flour to make. They can often become clumpy if not prepared properly. And maybe we've had some clumpy sauces with all this flour kind of clumped together. And in addition, they have an obvious flour taste to them. cooked flour, but flour nonetheless. So it's difficult then to create other flavor profiles unless you complement that paste. So they don't lend themselves to creating any flavor profile because there's always that flour taste in them. So these are some of the issues with the starch-based thickeners. All right, let's move on to modernist thickeners. So I'm going to talk about bechamel sauce again with our modernist thickener, but rather than thickening it with starch granules, which is what the previous discussion was about, we're now going to thicken it with xanthan gum. And I just want to point out that this picture shows this green color. That's just the color of the liquid. That's not the modernist thickener. So that's not meant to trip you up. This modernist thickener can go into anything. It's not going to change the color of the liquid itself. All right, so I'm going to pause here and I'm going to post a video of using a modernist thickener like xanthan gum to thicken a sauce. So please check out that next video, and then I'll get back into the discussion of the science behind that video.